block of mass M is at rest under the action of force F against a wall as shown in the figure. Which of the things is incorrect? Incorrect. Alright. See, what I was telling you was block is at rest. These two words refer to what? These two words refer to translational equilibrium. Okay, at rest means equilibrium is there. Okay, which means whatever forces that are acting on the body, they should vectorially add to null vector. Correct? So let's show the weight here. Weight is going to act downwards. Okay, now here is the thing. Here is the thing. We know that, okay, we know that the friction is going to act in the opposite direction, right? The friction is going to act in this direction, and it is always at the surface contact. Remember the figures that I showed you in the theory? This is going to be the frictional force mu1. And now please understand that the normal reaction needs to be shown slightly eccentric. Do you remember this figure that I had shown you? If not, let me revisit it. Okay, now this is actually in the vertical case, the block is about to move rightwards. In this case, the block is about to slide down, but you have to correctly recognize the figure, the location of the normal reaction. Qualitatively, not quantitatively, of course, qualitatively. So that should be the correct representation of the forces acting on that particular block. Is that clear? Now come to the first option. Is small f equal to mg? Of course, because vertical equilibrium should be there because the block doesn't move. So option A is correct. What about option B? Yes, that is also correct. That is also correct. Option C, F will not produce torque. It's true that is not going to produce any torque if we measure it about this point or about any point on this line. Okay. But what about the normal reaction? Is it going to produce any non-zero moment about this? Yes. Okay. Well, they should have been more specific about it. Okay. But in this case, if we consider moment about CV, okay, moment about this point, moment about center of mass, say, F and N have non-zero values. Do you realize this now? Because for normal reaction, if I consider this, then moment due to N will be Nx. Okay. And if I call this Y, then moment due to frictional force will be mu n times y. Is that clear? And torque is responsible for what? Torque is responsible for rotation. Okay, so out of the given options, F is not going to produce any torque, but N is going to produce torque. So correct option is, or incorrect statement is N will not produce torque. So correct option is D.